Good evening, dear participant, and welcome to this last session of the ongoing faculty developer program, biostatistics workshop from basic to advanced techniques. This is the 10th session of the workshop, practical applications and project day. Various sessions, almost 9 has been organized, and in the several sessions, we cover a lot of things about the statistical part, as well as how we can use R programming for this analysis. So today, main objective of this session is practical applications and project day. Various project related to health science, business or agriculture will be demonstrated. And resource person in this session today, we will have Dr. Ajay Kumar, Faculty of Information Technology and Engineering, Gopal, Narayan Singh University, Jamuhar, Rohtas, India. So before inviting today's resource person, I would like to have a brief introduction about Dr. Ajay Singh. He has completed his Master of Engineering and PhD in Computer Science and Engineering from Thapar University, Patiala, India. Currently, he is working as an associate professor in the Faculty of Information Technology at Gopal Narayan Singh University, Jamuhar, Bihar. He has over 14 years of experience in industry, academics, research, and administration to his credit. His area of expertise include cloud computing, big data analytics, software engineering, and machine learning. His current research focuses on ultra large scale storage management in cloud computing and bioinformatics. He has published and presented a variety of research papers in different international journals and conferences proceeding. Dr. Kumar has reviewed articles for many SSA journals like Soft Computing, International Journal of Intelligence System, Cluster Computing, Frontier, Journal of Bioengineering, PRJ Computer Science, IET Software, Concurrency and Computation, Practice and Experience, etc. He has vast experience in machine learning, deep learning, data science, and many times we also invite in different type of the activities we usually organize on this platform. And I hope that his expertise will be very insightful, valuable, informative, knowledgeable to all the participants. And now I would like to invite our resource person. Welcome, dear professor, in this session, and welcome to all the participants in this last session of our ongoing workshop on biostatics. So welcome again, dear professor, and now over to you. So now you can, also I request to all the participants, if you have any kind of question during the session, you can unmute your mic and put your query directly to the resource person. Okay. But keep muted your mic whenever you don't have any query or any question from your side. So whenever it is required, you can unmute your mic. Thank you. And along with you can put your questions in the chat box also.
Yeah, thank you, sir, for introducing and giving such opportunities. Okay. So I am audible.
Yes,
Please
sir. You are audible, and please share your screen.
Yeah.
Sir, please share the screen.
Yes. So my screen is share.
Yes, visible.
So good evening, all of you. Uh, so let's start these sessions because today is the last day, day 10. So today mainly I will discuss some practical applications related to biostatistics. So how statistics can apply in medical science. So now, firstly, what do you mean by biostatics project? Because you have already attended so many sessions related to biostatics. So generally, biostatics projects involves the applying statistical methods to biological health and medical research data. The goal of is to analyze medical data related to public health, medicines, biology, and genetics to draw meaningful conclusions, identifying patterns or test hypothesis. So I'm not going to any descriptive. So basically, today's session is fully hands-on session. So we have only 2 3 slides here. So this is the basic purpose of the biostatics project. So we have to analyze the medical data. So the medical data may be like related to health, any disease like diabetes, cancers, heart disease, and sometimes we have also analyzed the medicines, drug discoveries projects. So this is also very useful, and genetic like DNA analysis, gene sequencing. So there are various projects related to healthcare sectors, and definitely stats play a very important roles for this. And also we have to identify the a hypothesis. So this is also play a very important role. Suppose I am giving sometimes what is a hypothesis. So suppose if you are talking about like diabetes. So if you are saying you this is suppose you have a hypothesis, if people are eating too much sugars that people will become diabetes. So definitely you have set that hypothesis. And so now you have to prove that hypothesis with the help of some statistical approach. So without approval, without proving, it is not as so your research is not complete. So stats play a very important role in this area. So now these are some projects. So you can continue with. So you can see like heart disease predictions using machine learning classifiers, diabetes predictions using linear regression, detections and classifications of the cancer cells MRI. So there are several projects, problem statements related to healthcare. So you can apply some whatever in 10 days. There are so many methods. I have also attended some sessions really that are really wonderful sessions, and definitely we can apply all these things, all these approaches, and we can solve some issues that are listed here. So these are the some problems that you can work over these problems, and I have also given the references. You can download this problem synopsis. So I'm just opening. It will take 2 3 minutes more. So this is the leading India projects. So you should also work. You can use these websites. So this is the leading India projects, totally based on machine learning. So first, these are the research projects. There are several projects mentioned here. So you can see, I have some of the projects I have copied from here. So once you click here, you will get complete synopsis. You can download that files. You can see these are the synopsis, and you can work over these problem statements. So what are the problems here? So mentions and some backgrounds are also given here, and what the methodologies you can use like data collections, data selections, and developing CNN based cancer detections implementation. So these are some methodologies I already mentioned here. So you have to start working on this because the problem statements already you have just find the model is also given here. So how you can work, And what type of data sets you can use? Data sets are also mentioned. You can download that data sets from Kaggle's. If you have your own data set, it's a good things, because data sets really, it's a very important thing. So now, which softwares and hardware softwares you have to use? So these are some softwares you have to apply. You have, so basically like TensorFlows, OpenCVs, Pythons, Anacondas, and GPU. Definitely GPU, because the data sets mostly in the forms of image. So GPU is also required here. So there are several projects here, so you can download it. Okay. So now today I will discuss like heart disease predictions. Uh, so this heart disease predictions using machine learning. So I will apply some like 5 different machine learnings to predict the heart disease. So now, so what are the major steps I will follow here? So importing the libraries, uploading the data sets using pandas library, taking care of the missing values, duplicate values, data preprocessing, encoding and categorical data, feature scalings, and definitely data sets we have to like splits in the forms of like training testings. So whatever ratios I will use here. So after this, I will also implement linear regression models as support vector machines, decision tree, random forest, and gradient boostings. And then we should find the predictions with the help of some new data. So these 14 steps in these sessions I will cover here. Okay. So now let's start with sessions, the hands-on sessions. So one by one, all these steps I will cover here. So now here I am using the Anaconda navigators. So, and Jupyter Notepad I will use using Python programming, Python 3.1 ever. Yeah. So this is the Jupyter Notepad main directories. So just I am using Python here. Okay, so just I have renamed this. So now let's start with first steps. So we have to import some libraries. Definitely, I will import several libraries time to time. So currently, I'm importing only pandas, because we have to import heart disease data sets here. Import pandas as PD. So you can take anything, variables, and it is not necessary. So you have to apply only. So just check. So pandas library imported successfully. So 1 minute. Just I am like stop the videos because their internet. Okay.
Yes, sir, you can
Yeah.
stop your
Yeah.
video,
Yeah.
no problem.
Because the internet bandwidth is
Yeah,
taking.
yeah, yes, sir, no problem, no issue.
Yeah. So now after this, just you check it. Your library is imported successfully. So because we are not getting any errors. So now just take one of any variables and you have to import data sets. So one more things before you can see data sets I have already downloaded here, like hard data sets. You can see, yeah, this is the hard data set that I have already uploaded here, downloaded here. So now once suppose in your laptops you don't have, so how to upload? So there is a options upload. Once you click here, you can upload here. Why I'm saying? Because that Jupyter Notepad working on the local host. So you have to import that files inside their local host directories. Okay, that's why. So but whenever where you have a data set in your uh, own directories, you just upload here. So this is the options already given. If you are using any other like PyCharms, PyTorch, so no need to, because you can directly give the complete path. So I have already imported. So this is the hard data set. This is the CSV file. So comma separated values you can see, and these are some features. Okay, so and their values are already given here. So now I just import this file. So I just taking one variables like data is equal to pd dot, because I have already imported pandas library, pd dot read underscore csv. So because our data sets in csv forms, hard dot csv. So if we are using a normal Python shell, so you can give the complete path here. But in case of the Jupyter Notepad, so you can firstly you should upload, and you can give simply the file names, whatever file names you have, data sets. So now you just run this. So we are not getting any error. It means our data sets uploaded. So you just check it. So your data set is uploaded or not. So you can see our data set is uploaded. So we have 1024 instances here. So you can see. So now we have to use some pre-processing concepts. Okay. So now firstly should check like missing values. So is there any missing value in this data set or not? So how to check it? So data dot is null dot sum. Okay. So simply should check this. So there are several features here, and there is no any missing values here. Okay. So you can see here all are zero. So one more thing, suppose I just some values, you can see intentionally I just delete it from hard data sets. Like 52, I just remove it here, and one more in second features here. Okay, so after this I will correct again. So there is a 52, and I just remember it. So what values I have deleted, and you have to save this file, and again you can run this code. So you can see the changes. So because I have to upload that data sets again, because yeah, now you can see, once you can see there is a none values, it means none means missing values. Okay, after this you can execute these commands again, you will get like one. Okay, so you can easily find the missing value here. So whatever missing values in your data sets, you can easily identify with the help of this code data dot, because data it contains a complete data sets, and is null, and whatever whenever is null, basically that specify the true and false, and whatever number of null values, simply count it and give the sum values, total values. Okay, so now after this I just again because actual in original data sets there is no missing values, so again I just revert back, and again I uploaded. Okay, so you can check again, there is no missing values. Okay, yeah. So now after this, suppose you should also find the duplicate values. Because if you have any duplicate values in your data sets, it will also occur that affect the accuracies of your models. So you should also find the duplicate values. So data dot. So firstly, you should find if you have any duplicate values. So you should use any variables like duplicate data is equal to data dot duplicate dot any. So now, whatever duplicated data that is there any duplicated data that can store in here? You can easily find that data here. So now, basically, I have mentioned here any. It means you can see it is look like a true and false something. So once you execute, you will get is there any data duplicate or not. So now you can check what values either true and false. Okay. So true, it means yeah, definitely we have our duplicate values. Okay, so definitely we have to remove all the duplicate values because once you go through, it is very difficult to find the manually. So whatever duplicate values here, so there may be somewhere some because same patient's data may be multiple places, so it is very difficult to check manually. So definitely with the help of codes you can easily find. It means your data have duplicate values. If you want to which values, so I think that values not we don't concerned about so which values duplicate because simply fine yes, so you have to remove that things. Okay, so now how to remove duplicate values? So simply you have to apply drop duplicates. So data, because this is my original data sets, so I'm just removing duplicate and storing again in data variables. Okay. So either you can also take some new variables here. So data dot drop duplicate drop underscore duplicated. So it means your all duplicate one minute duplicates no. Yeah. So now again you can execute this code. Uh, so now you can check is because I have already dropped all the duplicate values. So you can run this command and again check your data having duplicate or not. You can see there is a false. It means we now our data don't consist any duplicate values. Okay, so you can see that there is a false. It means you can see again whatever data you have. Okay, so this is the totals. So all duplicate values are removed. So you can see here there is only 302 rows, and previous data you can see there are 1024 rows into 14 columns. Now you can see, so there are so many values are duplicates. So all duplicates are dropped here. So I think there's no any issues up to here. So now we have to apply some pre-processing, data pre-processing concepts. So pre-processing means you can see here there are several data fields having categorical. Like first age is not categorical because there's multiple age. You can see like sex, like 1 and 0. CP is also like 0, 1, 2 something because these are some categorical data. And like traced BPS that is also not categorical. So some fields are categorical and some of are non-categorical data. So you should classify all these features. So whatever categorical data you have, you should store in a separate variables, and non-categorical you have to store in other, because some of models cannot apply. Like suppose if you are working on some regression models, so it is very difficult to give the categorical data and cannot give the more highly accurate values. Okay, so it will better you should classify both data. So now, like cat, I have just using two variables. Like this is one of the variables, and continuous. continuous Continuous means like suppose if you have age, like age, price, cost, that are some continuous values. Here age is continuous and the several features are continuous. So now I've just used two variables and that can store all the features inside it variable. So all categoricals in cat val and all the continuous in con vals. Okay. So just I'm using a for loop column, column in data dot columns. If data columns dot and unique. So you can take any like so categorical. So sometime maybe 0, 1, 2, 3. So you can take any specific values here. So I'm maximum I'm considering here like 5. Okay. So I will discuss all these things. So what I am using here 5 data columns here. Now cat underscore val dot append column. So now else continuous, it means continuous fields that could be here append okay. So now I just explained this code. So basically we have taken two variables. So all categorical data I will store here and all the continuous data in this variables. So I'm just using a for loops here, like column in data dot columns. Basically we have to go through all the fields, all the columns features. Okay, if data columns that like in unique, basically I am using like categorical. So sometimes 0 1, sometimes 0 1 2, sometimes 0 1 3. So basically, so we are just following some categorical. So how much unique fields in that particular features. So I'm just considering maximum 5 here, because most of the I am seeing here like all the features. So you can find so how many features, how many values that specify the categorical data. So I will also check it. So what is there any categorical data that will store here? Because cat underscore val dot append columns. So whatever columns having maximum 5 values in their fields, so that will store in cat val, otherwise in continuous. It means they're having maximum more than 5 date values, so that will store here. Okay, so now, so you can just run this code. Okay, so you can check cat underscore val. So what values store in this? So all these are categorical. Okay, so all these are categorical. So like there is a 1, 2, 3, 4, 5, 6, 7, 8, 9. It means 9 features are having categorical values. You can see here, sorry, yeah. So definitely like sex, this is also categorical, like one, you can see the second features is the sex, and CP is also categoricals. You can see 0, 0, 0, it means 0, 1, 2, something like this. And traced BPS, this is not categorical, so you are not getting here. Like FBS, this is also categoricals. So you can see this is the sixth, like this. Okay, so all the categoricals values stored in cat values. Similarly, like on val, so you will get all the continuous field here, like age, traced BPS, like calorie. So all these are in this continuous variables. Okay, so now you can find the like uniqueness of the particular fields. Like in sometimes you can see, I'm talking about like CP. So definitely, like sex, there is only two values, like 0 and 0, 1. It means sometimes you can see like male, female, something. So we have only two values. So you can check all these things one by one, especially for categorical data, like data. Uh, you can use like sex dot unique. So you will get how much values consist by. So you can see only there are two values inside sex features. Similarly, I just using a CPs. So we have like four different values, like 0, 1, 2, 3. Okay. So you can also check like some others like FBS. So there is also only two, and some other like CA. As also checking this like CA. You can also see there are five different values. Okay, because I have taken less than equal to 5. You can see here less than equal to 5. It means maximum 5. I am considering the categorical data with 5 different values. Okay, if you can take like you can increase some other values, but I think there is no rest of things are having more than 10 different values. So you can take as depending upon you how much values you want to. So you can see there are several values consisted by some particular specific feature. It means CA features having these five combinations of these five values. Okay, so all these five value contain it only. So now we have to apply some encoding methods here. Why I'm saying, because if these are some different categorical values, so it is very difficult to get like getting a high accurate values, because if you train this a model with the help of this data, so it is very difficult to train the models. So we have to apply some encoding concepts here. So how to encode? So because we have some different values here, so we have to create some new features with the help of these values, like 2, 0, 1, 3, 4, because we have to generate some new features. Why I'm doing this? Because there is a collinearity concept. If you are not generating some new features, so that features will not affect. Okay, so that's why you have to encode all these features. You have to make some new features uh, to all the categorical data. Okay, so how to do it? So basically, just you should find how many features you have categorical and how many features you don't have categoricals. Okay, so definitely like target values you cannot change, because target, you can see I'm again going in So target, basically this is the outcome. So you should not change here because this is the outcomes. It means the patient's having a heart disease or not. Okay. So we cannot make some separate features. Okay. So now, so one more things, I'm just check. Okay. Yeah. So now what I will do here. So like categoricals val dot remove target. So basically we are just removing this, and rest of whatever categoricals we have, data is equal to pd dot. So we have to apply some dummy data here. Drop no, first equal to true. So one more that I am also removing, like categoricals like I'm just using first features like sex, because this is also categorical. Because why I'm removing this, because currently I am using only one features to train the all the data, all the models, and after this I will also use all the features, so don't worry. Okay. Okay, so now just run this code. Okay, sorry, there is true is having, because there is a case sensitive. Yeah. So why I'm getting these errors? So one more thing, just wait. It's fine. Okay, so now it's fine. Actually, I have changes something. So now again I am getting the errors. Okay, yeah, it's already run because I have already created these things, whatever I am, because due to some, actually, I have clicked two times here. So because that data is already removed and again I am clicking here, that's why we are getting the errors. So now you can see here, our data is already encoded. So what I am saying, you can see like CP11, CP21, CP31. So all the features that I have already, because I have clicked two times in on run. That's why I am getting the error. Because that feature is already removed and again I am clicking multiple times. That's why I am getting the errors, because our data is already encoded. So whatever like categorical values that have already encoded. So why I am not encoding sex, because this is already 0 and 1s. Okay, sex as well as targets. So that's why I have just I'm not taking this. Target is also, you can see, and rest of all the features are having more than two values. So all are encoded here, you can see here. So like CP having three, so you should, or you can check here, all are. So this is the things you can find. Uh, so all are encoded. So now after this, what I have to do here. So now you have 23 features, 302 rows, and now I have added encoded that data sets in multiple columns. So all the multiple values have encoded here. So now we have to apply some feature scaling. So feature scaling in the sense, whatever values you have, like you can see, like test BPS, so and calories are having 212 something. So these are the higher values. So it will better, you can transform these values in smaller values. So basically we are scaling in the sense, it means we are transforming that data. So we have some methods, standard methods to scale all these values. Okay. So firstly, you should find, you have to import some libraries like from sklearn dot pre-processing import standard scalar. Okay, so just you have to import this libraries. Okay, standard scalars. I just run this code. Yeah. So our data sets is already imported. Now, how to scale all these data sets? So basically, just you can use, I'm just using one variable, st is equal to a standard scalar. So then data count underscore val is equal to st dot fit underscore transform. So once you execute this code, your data will automatically transform. So now you can check, just run this code. So I have something missing here. No, sorry. Actually, I have used the continuous variables, CON. Okay, whatever continuous values, you cannot encode the like categorical values. So you have to encode only continuous values, because continuous values having some higher value. You can see like 120s, 142, 55, like this. So all these values are will be transformed. Okay. So now I just run this code. Standard scalar. Fit transform. Okay. Yeah. Now it's okay. So now after this you can check all the values. So data, just print these values. So all the continuous values are transformed. Okay, so you can see because we have so many methods to transform your data. So one of the methods is standard scalars that I have used, and all the values are transformed. You can see that are very small values, like 0 point something, 1 point something. So these are some smaller values. So definitely, suppose if you are calculating, computing based on these value, it will take a higher cost. Okay, so computation, I'm talking about computational cost. So whenever you are executing any data sets, you must scale all these data. It will better if you transform. So we have some standards. So one another like lambdas functions are also available. So logs values, you can also take logs, and there's so different transformations are available inside SQL. Okay, so if you have some your own methods, you can also apply. Okay, so once you transform the data sets, now after this, so now these data sets can apply for train the models. Okay, so now you can use data sets. So what things I have completed till time, so you just check, revise one more thing. uh, so firstly, I just find all the missing values. Is there any missing values in the data sets? So there is no any missing values. After this, I've just checked all the duplicate values. Yeah, there are so many duplicates. I have removed all the duplicates, and then I have to encode all the like categorical data sets. Okay, so after this, firstly, should I have just categorize all the continuous features as well as categorical features in separate variables. So all the categorical variables are encoded. Okay. Then after this, I've also applied some pre-processing concepts. So transforming all the like non-categorical values, it means continuous values. And now you can see this is the final data sets. Now these data sets can be applied over models. Okay. So now, after this, I just split this data sets in different uh, classifications. Now, suppose firstly I just use X and as well as Y. So data dot drop target. So now why I'm using this code, because so all the independent variables I'm just storing in X, because when we split this data sets, we have to split in four different parts. That's why I'm just dropping the target, because this is the dependent variables. So I just drop these features, and what all the like independent variables I am storing in X. So now you can run this code. You will get once you like X. So there is no targets. You can see there is no targets. You can see there is no target. Okay. So I just remove target from this. So it means we have only independent features here. Okay. Now similarly, I just store the targets in Y data target. So we have only one features here in Y. So you can see only targets here. Okay. So all the dependent and independent variable I have separated here. So now basically we have to apply some training and testing concepts. So firstly I just so what do we mean by training and testing? So here we have to split these data sets in four different parts. So just I am using four different variables like x train, comma, y train, comma, x test. You can, this is the user defined variables. So you can take any as per you, y test. So these are four variables that I have taken equal to, and just I am using a functions train underscore test underscore split. So this is the functions. Okay. So our all the independent variables in x, independent in y, and just I am using test size is equal to like 0.2%. It means 20%. Okay. And one more random state is equal to 42. And you can use anything. So basically, this is not compulsory. So you can like after 40 times, basically random states means you can execute 40 times with different values. After 40, your values may be repeat like this. So random states you can use anything here. Okay. So now I just run this code. Uh, train test split is not defined. So definitely we have to import that libraries before using this because I have imported this. So from sklearn dot model underscore selections import train test and split. So from sklearn.model selections import train test split. Okay. So now there is no any errors. So firstly, before going to next page, I just clear what do mean by training and testing. Okay. So this is very important point. So suppose we this is my data sets. Okay. Uh, just I'm taking few features here, like suppose we this is the data sets. Okay, so I'm just clearing what do you mean by training testing. Okay, so we have three features and one like three independent variables, like these three are independent variables, okay, and target are dependent variables, okay. So based on these features, their patients having heart disease or not. Okay, so now what I'm saying, basically, these data sets we have to split in four different parts. So just I am taking like a 25% data for testing purpose. So it means we have to use 5 instances for testing purpose. Okay, like this. So just I am putting some color here. Okay, so I'm just using this. So now we have this data for training purpose. Okay, so this is the training purpose. So now after this, because again you have to split, like I'm talking about like this. So these things that I have to use for X test, that with that data I will store in X test variables. Okay, just, and again this I will store in X test. Okay, so we have four different colors now. So X test, sorry, X train, Y train, X test, and another is Y test. Okay, so we have four variables. It means the yellow color that I am talking about, like these portions. I'm talking about like these portions. So these, all these values, okay. So that will store in X train, and these values, these data, I will store in Y train, okay. And this data I will store in X test, and this in Y test, basically. So why I'm doing these things? Suppose if you are, suppose if you have any models, like suppose I have developed models, well, because this is my models, machine learning models. Okay. So now after this, we have to train the models. So with the help of these data. Okay. So just I am just passing all these values to model algorithms. Okay, because we have 15 instances here, so all these 15, based on these 15 instances, just I train the models. Okay, so 15 times, suppose if you are train the models like slope, ca, thal, like these values you are putting, and your models train. So okay, that on the basis of these values, patients have no heart disease. Similarly, like if you are putting these values, and again your models like getting, okay, these on the basis of these values there is no heart disease. So on the basis of these 15 data, you just train your models. Okay, and once your model trained, what you will do, so you have to apply some testing concepts. You are just putting these values to models, and your model gives the predictions. Okay, so once in case of like first testing, like T1, this is the first testing, and your model givings like there is no heart disease, and you can see the actual value is 1. It means the person's having heart disease. It means your model failed to predict correct values in first test. Similarly, if you are putting second values, these values like 2, 1, 2 something, and again suppose your models giving, yes, the patients having diabetes. Okay, so what it means, you can check here the actual values also, yes, it means patients having diabetes, sorry, heart disease. So your model is pass because your predicted and actual should be equal. Okay. So now you are just again passing these values to models. So this is the second test. Now you are applying third test and your model giving like yes. So what does it mean? You can check the actual value is no, but your model saying that person is also having heart disease. So what does it mean? It means your model is not giving the correct answer. It means your model failed here. Okay, similarly, fourth, you are just passing these values like test fourth, and your model giving there is no diabetes, suppose, sorry, heart disease. So what does it mean? Again, your model fail because the person's having heart disease, but your model saying no, model predicting no. Okay, so now again, fifth test, your model giving yes, so persons having heart disease, it means you can check the original is actual is yes, and your model also saying yes, it means your model is pass. So now out of five tests, how many fails and how many pass? You can see here, out of five there is five, so three is fail and two is pass. It means your model having 40% accuracy only. Okay, 40% accuracies because out of five testings only two are passed. It means two instances in two cases giving the correct answers. Okay, so this is the things. So that's why we have to train the we have to split the data sets, and after splitting you have to train the models. Okay, so during trainings you require these things. It means two variables like x train as well as y trains. So now again moving on my Jupyter notepad. So now our data sets I have already split it here. You can see you can, once you print the values, you will get x train. So you can see these are the values. It means 241. Okay. So how many instances you have? So I think 302. Earlier you can check here. 302. It means 20% data I have taken for testing purpose. So it means in for training purpose, I'm using 241 instances here. Okay. So similarly, you can check like y trend. So again, you will get 241. Sorry, uh, sorry, y train. Yeah, yeah. Just there is something missing here. Okay. Okay, this is fine. And y test. Yeah. So one more thing, you can say basically train test split that split the data sets randomly. It is not like starting to ending because you can see the sequences are different. Okay, like 75, 1 and 40 because randomly selecting. Again, so if you are executing multiple times, you will get different data for X train, Y train, Y X test, Y test, lump sum. Okay. So now once you split the data sets, you can use the models here. So now let's start with, you can use any models, any classifiers here. So now I'm just using logistic regressions. So before we have to import the logistic regressions. Okay, so I've just imported the logistic regressions. So now you can take the any variables like LG is equal to logistic. So just I have taken logistic regression models. Now you have to fit these models. It means basically we have to train the models. So we have definitely you have to use both training variables data sets like X train, comma Y train. Okay. So based on these variables, because during training you require these two data sets. Okay. So you just just check it. Why I'm getting errors? X train, Y train, X test, Y test. Yeah, it's fine. Just check it why I'm getting the errors. Okay, here it's fine. LG dot fit X train Y train. Those data sheets is already validated. Okay, sorry. One thing I have missed here, the sequence of this. Actually, that X train, sorry, uh, X test, because this is the sequence we have to follow here. X train, X test, then we have to use the Y train and Y test. This is the actually I have missed this sequence. Okay, so we have to follow this sequence because whatever values returned by these functions in this sequence only. So firstly X train, then X test, then again like Y train and Y test. So I just correct these things. So, okay. So again I have to train split the data sets. Now just again now after this I think your error resolves. Okay, so there is no any issues because I have sequences are different. That's why this is getting the errors. So now our models is trained. So I'm just taking one variables like predictions y underscore predictions. I'm just taking one variables. So once your model trained, so you have to check the like lg dot predict x underscore test. So you have already, because you are just putting these values, because you have to test based on not because you have to predict the values based on this. So whatever predictions you are getting once your model trained, okay, so just check it. So what predictions you are getting here, again you should predictions. So these are the predictions, okay, so based on your test, okay. So now you have to find the accuracies. So how much accuracies on this? So actually, one more things you can see Y test. This is your actual data. Okay, this is your actual data. So you can see the first values you are getting your predictions, second and third are correct. But fourth, you can see here your model is giving 0, but in actually that patient's having heart disease, but your model is saying no. And fifth is also correct. So similarly, you can see here. So you definitely you cannot get the 100% accurate, because this is the machine learning models. So this is the predictions. This is the predicted values, okay, and these are the actual value that you have stored in the data sets, okay. So again I'm just repeating what basically, so this is the y test values, okay, and these are the y predictions that I have predicted with the help of models, okay. So now you have to compare these things, y test and y predictions. So how to get the accuracies? So again we have to import one libraries from sklearn dot matrix import accuracies underscore score. Okay, so you have to import this lab performance matrix. So now you can find the accuracies underscore score. Test comma predictions. So definitely accuracies, you have to use the actual values that you have stored in y-test and the predictions which is given you got through models. So you have to pass these two data sets, okay. So now you will get the accuracies of your models. So there is a 95% you are getting here, okay. So this is the accuracies you got here. So now after this, this is the logistic regressions. Same problems I am applying on SVM, support vector machines. Okay. So quickly I just import sklearn, import SVM. Okay. So just so SVM. I have imported like SVM is equal to SVM dot SVC. Basically, the actually defined in SVC forms. So support vector classifier. So we have to use this thing SVC. This is the system defined SVM. Basically, that this is the objects that I have defined here. So svm dot svc, this is the system defined, and whatever models that I am storing in these variables. Okay. So now you can again you just train these models svm dot fit. We have already splitted our data sets, train, comma, sorry, y train. Okay, so now our SBC also trained. So again, just I am using again predictions, and we have to find the score. So here I am using like y underscore predictions. This is my second predictions, so that's why I'm using second, and svm dot predict x underscore test. Okay, so you will get the all the predicted value. You can check here predictions 2. Okay, so now you should find the accuracies. So we have already imported like accuracies matrix. So again, you don't require again accuracy underscore score. So again, we have to pass y test, which is the actual data, and y predictions 2, because this is the SBC predictions. So now you can find the accuracies of, so 86 approximate 87 you we are getting accuracy with the help of SVM. Okay, so these are the accuracies that I have used here. Now I'm applying some other, like some one, actually these are linear, so I also trained one more another models like non-linear models, like decision tree. Okay, because these both are linear models. So non-linear models, basically you no need to like basically we have already encoded data sets 0 1 something, but in non-linear models it is not required to encode the data sets. Okay, so you can directly use the actual data sets. It means that I have already stored in data. Okay, so now I am using like decision tree models. So whatever data we have, you can see again I'm just uploading because I have already changed so many things and encoded scaling everything. So now again I'm like uploading the data sets, read underscore csv dot csv. Okay, so why I'm again importing, because we have encoded that previously this data. So again, that's why we have to import again. So you can use the like data one. Okay, so you can keep the data as it is. They may be required. So now data one is equal to data dot drop all the duplicate values. Okay, so now I have remove all the duplicate values. Again, x is equal to data dot drop target and y is equal to data target. So again, I have stored x, y in two different variables, and similarly, just I am using same training test split, just copying because I have already imported, so I'm not importing again these functions. Okay. So I just run this extend x test. Sorry, because you have to define the axis also. Yeah. Target y is equal to data target, but still I am getting error. Sorry, because we have used data 1, that's why this is the main issues. Data 1, data 1 draw target, target x is equal to 1, invalid maybe meant this. Okay, okay, sorry. There's something issues here. This should be small brackets, yeah. Okay, so now I'm just again importing from one library like sklearn dot tree import, because there are various models are available related to decision tree. So this decision tree classifier. Yeah. So I have imported successfully this libraries. So now, like decision tree is equal to, so now just make this models. So now you can run this code. Again, we have to fit the models dot fit x underscore train comma y underscore train. So models already trained. So again, I just predict y prediction 2, sorry 3 is equal to dt dot predict x underscore test. So again, I just use this code. So whatever values that I got here, so you can check. So you got the predicted values here with the help of decision tree models. So these are the predicted values. So again, you have to find the accuracies. Score the actual values that I have stored in white test and predicted prediction 3. So now you are getting the 78%. Okay. So these are some accuracies that you got. So there are several models are available, like you can apply KNN, CNN, gradient boosting. So there's various models are available, and you can apply in such a way, and you will get some more accuracies. Okay. So whatever values you have, you should find. You can apply. Uh, and once you got all these values like accuracies, you can consolidate all this and which models are more appropriate, and based on this you can also use some like ensemble modeling. So I think we don't have sufficient time, so it will take at least 1 hours to implement ensemble modelings. So this is the like these three models you can see having different accuracies. Yeah, definitely you will get some more highly accurate values if you are applying some ensemble modelings. Okay, so that's all from my side into these sessions. Now we this is a time for like questions. If you have any doubts, you can ask me, so I will resolve all the doubts. Okay.
Uh, Thank you, dear professor, for your nice presentation. And I would like to invite the participant. If you have any question, please feel free to ask. You can unmute your mic and put your question for more discussion. This is important to clear your doubts. Yes, please. Uh, Dear professor, please unshare your screen. Professor Ajay.
Yeah, yeah, I'm listening.
Yes, it's fine. Now, dear participant, please put your question. You can unmute your mic to clear your doubts. Or either you can put your question in the chat box. Yes, please. Actually, dear professor, the workshop was based on the using R programming, and previous all the sessions were based on by using the R programming and for the statistical part. But today you are using
Okay, so
Python.
I
Yeah.
can also implement this in R because I have a both. Yeah, yeah.
uh,
Okay.
I think some of the participant or most of the participant are not using Python, but I think there are many similarity between R and Python. For the data analytic, both are very useful.
Yeah.
But for the more explanation and more clarity, I would like to ask from the professor, our resource person. He can clarify about the confusion I think R and Python both are necessary for the data analytic and for the machine learning part. Sir, please clear the doubt regarding this confusion, which is better or both are mandatory or not. Sir, please.
Hello.
Yes.
No, is there any query from participants? No?
From the participant, we are not getting any query.
Okay, okay.
Yeah.
So,
But this question is a very common question from the participant and usually have the confusion because when we discuss in the previous sessions and we go to some questions related Python and R.
okay.
Um, the people who are using R, I think they some of are not familiar with Python, and
Okay.
some are interested to use Python, and some are not using R. So please
Okay,
justify this confusion.
yeah, yeah. So don't worry. So I will share you some very simple notes. So definitely, so Pythons and R, all there's nothing too much differences in such. Yeah, R having the R generally we are using for data analytics purpose and data science. So you can use both language. There is no any too much differences. Even codes are also almost similar. Uh, so if you are at the support of Pythons, I will send you some notes and you can easily get it. So and Pythons also most of the libraries are available inside Pythons as well as R programming also. So same way you can apply in R because R also having there are lots of bunch of machine learning models you can import. But yeah, definitely in R, the you don't import anything. Here you have to import. So this is the differences here. So because you can see everywhere, I have to import the library. But in R, if you are using R Studio, so no need to import. You can directly use that models and you can train the models. So this is the differences something. So definitely, yeah, R is also good. Uh, so both are. I think I am giving the weightage. Both are good. Okay, especially for healthcare sectors, because especially for neural networks. So I think I suggest to use like researchers should use the Pythons for especially healthcare projects related. Because I have seen there are lots of data sets that are based on Pythons as well as models like medical related models also developed in Pythons. So you can use that models and you can directly get some more highly accurate values. So I will
Okay.
share some notes that you can easily get how to write codes in Pythons. Don't worry.
Yes, sir. Sir, please provide the some more models based on by using Python, and if you have prepared models based on by using R programming, so I
Yeah,
think
sure, sure.
participant will have
Uh,
more support
I
and
will
they.
also send all these things in R also. Yeah,
Okay.
I will. Yeah, so both Python as well as R. Okay, so I will send you the codes like all these models in R as well. Okay.
Please send us all these through email, and I will provide it to all the these all content to all the participant. Dear participant, please stay connected. We will take a few minutes more because the validity of this function is also will be there for 10 minutes. So please stay connected so that we can have some suggestion from your side. Also, this is very important to improve the quality and to improve the upcoming workshops for different type of statistical and other part by using R and Python or other programming. This will help us. So feedback and other things are very important. So before starting the validity part, if you have any question, once again, I would like to ask from participant, you can unmute your mic, you can put your question, and then after we will start the validity and feedback from your side. Yes, please. Dr. Pooja Sharma, Dr. Bisavdev, Mandeep Kaur, Richa Saxena. Please, if you have any question, Ritik Kumar, Dr. Prakash Thakur. Yes, please. You can even unmute your mic. Okay, I think there is no more question. Dear Professor, once again, thank you very much for your informative, valuable, and knowledgeable session. All the content which you present are very smooth, and step by step you explain everything how we can integrate machine learning for the prediction. And I think the content in the entire session you present are really very understandable to all the participants, and they can easily integrate, they can use their for findings. And also, dear participant, if you have problems in the near future, you can contact directly to Ajay Kumar. We will share his contact detail, email address. Okay. So whenever you feel any kind of the problem or you have, you can easily contact us, or you can directly contact to the resource persons which we invited during these 10 sessions. So, dear Ajay, thank you very much for your valuable time. Now, before starting the validity, we would like to have a feedback from your side, because during the 10 sessions, we, the speakers, and myself speak a lot. But now it is time to speak from, we want to listen from your side. What do you feel? How much this workshop is valuable and informative for your use as you show your interest in this workshop? So we would like to listen from your side. You can unmute your mic, and you can present your thought about the sessions, about the speaker, about the flow of the workshop, and the content during the sessions which we present and we provide to you. So please, one by one, anyone who would like to present your thought, you can unmute your mic, and this will, and also we would like your suggestions. This is very important from your side. Yes, please. Uh, please don't hesitate. You can unmute your mic. Yeah. Richa Saxena. Yes, please. Bularin. Dr. Bularin.
Yeah, but
If possible, you can open your video also.
I'm somewhere that I won't be able to open the video, but I can speak using the audio. I'm outside the house, so sorry, I can only speak using
No
audio.
problem. Please put your thought. We are eager to listen to you.
Okay. Thank you very much. I want to say the past 11 days have been very wonderful. You know, the 10 lectures that we had, and this lecture today, I would say is like the climax. You know, very wonderful presentations all through. The resource persons, all of them were wonderful, and I hope, given the opportunity next time, we don't want to miss a workshop like this. And I'm saying this with all sincerity. Kudos to the host. I know the work is not easy, but you've been wonderful too. So thank you very much for the opportunity to be part of this workshop. Thank you.
Thank you very much for your feedback. Anyone, Dr. Elumalai? Ritik Kumar, Jitendra Kumar, anyone please? Dr. Biswadeep?
Good evening, sir.
Good evening, Ritik.
Yeah, the information provided by both of you are very attractive, and the sessions which we get are too informative. And the uses of Python, such as pandas and abbreviations regarding data analytics, we are getting are too informative and so engaging. Thank you for the session.
Any suggestion from your side for the upcoming event?
Yeah, sir. Just as previous, I want some workshop on Maple as well as Mathematica, such that we can enhance more our skills towards these.
Okay, thank you. These will be very soon in the coming near future. Himashu. Himashu, are you there? Anthony. Anthony Salom, can you please unmute your mic? Okay. So, thank you very much to all of you for your suggestions. The feedback form will be shared in the WhatsApp group, and you will put your suggestions. It is mandatory to all during in the submission of the feedback form. And also, this was the 10 days workshop on biostatics, and all the sessions successfully over. And the content which was presented during the past sessions has been provided. And if you have any kind of the challenge during the session, or some of the participants are not able to join this workshop due to the network issue or the other reason, because most of the participants who are taking participate in this workshop are faculty members or scholars, and some of the participants are from different time zone. There are about 9 countries from which the participants are taking participate, and about 100 plus participants registered for this activity. Some of are not able to join because of the different time zone. So we try to accommodate from our side by providing the recording, and some of the participants are attending these sessions through the live streaming, because parallel we have managed the live streaming sessions to all the participants. So several groups has been organized, uh, links to join the session through Zoom meeting, as well as for the live streaming sessions. Some are attending through the YouTube live streaming sessions. So the content as well, which was printed day by day, we provide to all the participants. And still, if you have any challenge, you can contact us, and we will try to accommodate at every level. So now I would like to invite Dr. Sonia Malik for the vote of thanks. But before that, if all the participants, I request please open your webcam, so we have a short screen for memory. Please open your webcam for having the screenshot. I request to all the participants, please open your webcam for having the screenshot. Phil Jacob, Vidya Shriam, Dr. Yes, thank you. Mandeep Kaur. Okay. And I request other participant also, Dr. Prakash, Jivarthana S, Emmanuel. Okay, thank you to all. Now I would like to invite Professor Sonia Malik for a vote of thanks about this ongoing workshop. Ma'am, over to you, please.
Thank you, Dr. Mehta. So, as we are going to include a workshop on biostatistics from basic to advanced techniques, which was jointly organized by MathTech Thinking Foundation and Baba Fried Group of Institutions. I would like to extend my heartfelt thanks to each and every one of you. Your active participation, insightful questions, and dedication have been integral to the success of this event. Over the last 11 days, we have journeyed through a comprehensive exploration of biostatistical methods from basic principles. I think there was some connection went in between. Are you able to hear me?
Yes, ma'am.
Yes.
Yes, so I hope you found the session informative and engaging, and that the knowledge gained will be a valuable asset in your future endeavors. Thanks to our esteemed speakers, Dr. Mahavir Singh, Ranvar, Dr. Poonam Singh, Dr. Priyas Sharma, Dr. Harpreet Singh, Dr. Ajay Kumar, Dr. Geeta Wall, and I also appreciate them for providing the content so that participants can see afterwards and benefit.
Sonia ma'am, you are again unmuted. I think you have some network issue from your side.
Okay, sorry, I think, yeah. I also appreciate the efforts of our organizing team, especially Dr. Madsen and the supporting staff who did hard work behind the success and I mean behind the scene and I know that everything ran smoothly. So I encourage all the participants and everyone to apply what you have learned and continue exploring the fascinating field of biostatics. And with this, I conclude my session and thank you everyone. Thank you, Dr. Machan.
Thank you, ma'am, and thank you to all. Dear participant, I have shared the feedback form in the chat box. Please submit the same, and also this will be shared in the WhatsApp group. So feedback is very important for us, and please submit it carefully because the information which you will submit in the feedback form will be printed on your certificate of participation. So please submit your personal information about your affiliation, etc., very carefully. So once again, thank you to all, and we would like to see you in the coming other workshops. Thank you. So now it is
Thank
time
you.
for the session. And lastly, if you have any issue, any problem, any question in the near future regarding this workshop or the upcoming workshop, please always feel free to contact us. And we are here to support you for STEM professionals, for our, we are supporting here each other. We also ourselves learn a lot from your side. So we are exchanging our thought. So collaboratively, we can build a beautiful STEM professional community, and we can contribute for the society also. So once again, thank you to all, and it is time to end the session. Thank you to
Thank
all.
you.
Thank
Thank
you.
you, Prof.